Hello everyone, welcome to Module 3, Part 1 of our Risk Assessment series. This is GCU from the University of Minnesota, and I will be introducing the control banding tools for assessing emerging technology for this module. In this section, our objective is to understand the purpose and process of control banding. Control banding is a simplified risk assessment approach used when limited toxicological or exposure data are available. It helps identify appropriate control measures based on the hazard level and potential exposure. Control banding is a qualitative risk assessment strategy used to manage workplace chemical hazards, especially when occupational exposure limits, OELs, are unavailable. Instead of relying on precise exposure data, control banding groups hazards and uses general control strategies, helping to ensure protection even when detailed toxicological information is missing. When a new chemical is introduced into the workplace, one of the first questions as an industrial hygienist asks is, what do we know about this risk? Usually, the go-to approach is to look up occupational exposure limits, OELs. These limits help determine how much of a substance workers can be safely exposed to. But what if no OEL exists? That's where control banding becomes essential. OELs define the maximum concentration of a chemical that workers can safely exposed to over the length of their working lifetime. If exposure exceeds this limit, workers may face increased health risks. Common examples of OELs include the recommended exposure limits set by NIEHS and the permissible exposure limits established by OSHA. These values are important tools in traditional risk assessment. So what happens when a new chemical is introduced in the workplace, but there's no occupational exposure limit available? This is actually quite common. In fact, most commercial chemicals and mixtures don't have assigned OELs. When that's the case, industrial hygienists can't rely on traditional quantitative risk assessment alone. This is where control banding becomes essential. It offers a practical, qualitative approach to manage these risks even without OELs. In control banding, workplace risks are grouped into control categories or bands based on two main factors, the hazard of the chemical and the level of exposure. A band hazard might refer to characteristics like whether the substance is a skin or eye irritant, highly toxic, or even carcinogenic. This helps industrial hygienists determine which types of controls are needed even when no OEL is available. In addition to hazard information, control banding also considers the potential for exposure. This potential is typically categorized as low, medium, or high depending on specific factors. Key considerations include how long the task takes, the duration, how much of the chemical is being used, the amount, and the form of the chemical, whether it's a solid, liquid, or dust, or vapor, for example. All of these influence the likelihood that workers may be exposed during a task. At the end of the control banding process, you will be provided with a recommended control measure based on the hazard and exposure information. This matrix here helps visualize how exposure potential and hazard probability are combined to guide control decisions. The goal is to move risks from red or yellow zones into the green by reducing hazard and exposure. Some common control measures include engineering controls like enclosures or local exhaust ventilation, general dilution ventilation, and contaminant strategies. If necessary, personal protective equipment or PPE may also be recommended, although it's considered the least preferred option in the hierarchy of controls. The control banding approach is grounded in two key principles. First, there are only a limited number of control strategies that are commonly used in workplaces, like ventilation, contaminant, and personal protective equipment. Second, many chemical hazards already have known, proven solutions. Instead of reinventing the wheel for each hazard, control banding helps match a hazard exposure scenario with an effective, established control method quickly and efficiently. Together, these principles make control banding a practical tool, especially when we don't have an OEL available. Control banding is most effective when it's applied in line with the hierarchy of controls. This means prioritizing methods like substitution, engineering control, and then PPE, rather than relying solely on protective equipment. For example, instead of controlling exposure through respirators alone, we might replace that chemical with a safer alternative. This approach ensures we're addressing hazards at their source and providing more reliable protection for workers. While control banding is a useful tool, it should never be seen as replacement for expert judgment. It provides general guidance, but in cases where the risks are complex or uncertain, it's important to seek advice from qualified occupational safety and health professionals. In fact, many control banding tools will specifically recommend consulting an expert when more detailed analysis is needed. Even when using control banding, professional judgment and practical experience are critical. This is because controls must be not only effective at reducing exposure, but also feasible to implement in the real work environment. In many cases, they also need to meet the standard of being reasonably practical, meaning they are appropriate given the specific conditions, resources, and risk present. This ensures that the selected control measures are both protective and realistic. And it's important to remember, control banding does not replace the need for exposure monitoring. Even when control measures are in place, monitoring is still necessary to verify that exposures remain within safe limits. Here, we compare control banding with occupational exposure banding, or OEB. Control banding focuses on recommending specific control strategies, such as contaminant or PPE, based on a particular risk scenario. It provides risk management guidance but does not define an exposure limit range. In contrast, OEB uses hazard data, like toxicology or health studies, to place a chemical into one of 5 exposure bands, each with a corresponding exposure limit range. Once a chemical is banded, users compare actual workplace exposures to that range, decide on controls if exposures are too high, and conduct monitoring to ensure those controls are effective. Importantly, control banding and OEB can be used together to improve workplace hazard management. An important note to remember is that neither control banding nor occupational exposure banding replaces health surveillance or exposure monitoring. These methods are tools to guide risk management, but follow-up is still critical. Both approaches require routine checks, especially when there are changes in tasks, materials, or processes, to make sure controls remain effective and risks stay under control.
This lesson has been created by the Interdisciplinary Training, Education, and Research Activities for Assessing and Controlling Contaminants from Emerging Technologies Program, a collaboration of the University of Minnesota School of Public Health, the University of Iowa College of Public Health, and the University of California, Los Angeles Fielding School of Public Health. Funding for InTERACCT is provided by the National Institute of Environmental Health Sciences of the National Institutes of Health. The content of this lesson is the sole responsibility of the developers and does not necessarily represent the official views of the National Institutes of Health.